For question number 4, we have one of those overlapping triangle situations. So I'm going to redraw these. And you know that when we have overlapping triangles, we're really always looking for a shared side or shared angles. So we have RKM. So RKM is this little skinny one over here. And what we know is that this angle R is going to be a right angle. We'll have to say that. So there's RKM. We have angle K that we know is congruent, and our other little triangle is OMK. So OMK, O is right here. Here we have M, we have K, and we know that this angle K is congruent to this angle M. And in fact, our shared side is KM. So already we know we're going to have angle, angle, side. We have a pair of congruent angles. All right angles are congruent. And our side is not included. And by that we mean that it's not sandwiched in between these two angles. So this shouldn't be very difficult at all. We know, let's say we have some right angles here. So angle MRK and angle MOK are right angles. And that, of course, is definition of perpendicular. And in this case, we do want to say that they're congruent because we're using angle, angle, side. So let's say they're congruent. So angle MRK is congruent to angle MOK. And that is the theorem that says that all right angles are congruent. And let's see, so there we have one pair of angles. We had another pair of angles in our given, and let's just say that Km is congruent to itself by reflexive. And then we are good to go. By angle, 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 side, angle, angle, side, we can say that our two triangles, RKM, is congruent to triangle OMK. So notice one thing, if we are using HL, we have to state that we have right angles. We don't have to state that they're congruent. If we're using angle, angle, side, and one of our pairs of congruent angles happen to be right angles, we do have to state that those are congruent.